Welcome to the revision of the Cōnsilium Aquīs Sulis GB Mainline Signalling Part 1 course. In the course we covered the following topics. Why do we need railway signalling? From the steam age to the information age, points, signals, routes and overlaps, the lock-in level, the aspect level, signal aspects, route indications and approach control, factors that constrain signal positions, banner repeaters, AWS and TPWS. Module 2, we answer the question, why do we need the railway signalling? And we saw that railway signalling proves track is clear for hundreds of metres ahead of trains and indicates this to the driver, enabling them to travel safely at high speed. It also is responsible for moving points, locking them in position and providing information to drivers to control speed appropriately. It prevents conflicting movements over junction and bidirectional sections of track, and ensures level crossings are closed to road traffic when trains are authorised to travel over them. We then moved into a short history lesson from the steam age to the information age, beginning with the key principles of railway signalling introduced to the steam age and still with us today: the block system, continuous self-applying brakes for passenger trains, interlocking of points and signals, and facing point locks. We looked at some of the 20th century modernisation, introducing electrically powered signals and points, enabling higher speeds, and also increasing levels of automatisation and centralisation of control thanks to electric train detection and relay circuitry. We then looked at the role of computer-based signalling and comprehensive automatic train protection, ATP, and cab signalling that started to be introduced in the latter part of the century, and then came to be standardised with the European Train Control System, ETCS, in the information age of the 21st century. ETCS also bringing radio-based transmission of signalling data and the advent of automatic train operation, ATO, on mainline railways. Module 3, we moved on to some concepts of railway signalling: points, signals, routes and overlaps. Points are moved and locked in position by the signalling system, either individually at junctions as pairs and crossovers or in larger group. And the term signal can refer to the physical device that communicates movement authorities to drivers, or be a physical marker at the end of movement authority, or simply a collection of logical states within an interlocking. Signalling route is a defined path over a track from one signal to another, and an overlap is a section of track beyond the end of a route overlapping a subsequent route or section of track that is reversed for trains in that route. We then looked at the locking level and the aspect level, asking the question what the locking level is, and learned how it presents unsafe combinations of states within the interlocking that could lead to unsafe combinations of commands get issued. It locks points, other movable infrastructure, and certain types of level crossing, and usually prevents directly and indirectly opposing routes being set. However, opposing locking can be overridden to allow us train into an occupied section or to shunt backwards and forwards in a siding. In the aspect level, we learned how the aspect level concerned not with internal states but with the external states of physical equipment, and the conditions needed to allow a signal to display a proceed aspect to authorise a train to enter a route. We looked at the points in the route and how these conditions include proving that points in the route are detected, locked and physically in their required permissions, and the additional requirements for non-permissive routes that included proving block sections are clear and exit signal lamp proving. We then moved on to look at specific signal aspects, the main signal aspects used to authorise trains to enter main and Warner routes, which can be either horizontal inclined red or yellow semaphore arms in the case of mechanical signalling, or green steady or flashing single or steady or flashing double yellow lamps in the case of colour light signals, or red lamps, a stop board or a distant board. We saw shunt aspects are used to authorise train to enter calling on and shunt routes. That can be either a subsidiary aspect on a main aspect stop signal, or an independent shunt signal, which may also mark the end of a shunt route. And we finally looked at poser, proceed on site authority aspects, for which a flashing shunt indication is displayed. We then moved on to route indications, accompanying signal aspects and approach control, and saw how mechanical signalling, a separate semaphore arm, is provided for each route from a signal, but in colour light signalling aspects are supplemented by route indicators that are illuminated or extinguished to indicate which route they apply to. Position light junction indicators, PLJIs, consist of 5 white lights in a straight line indicating the relative direction of main and Warner routes, and typically visible from a long distance, but rather limited in the number of routes they can indicate. By contrast, alphanumeric route indicators can only be seen at a shorter distance, but because they can display any combination of letters and numbers, can be used for a much larger number of routes from the signal. Where routing is high, we looked at primarily route indicators provided on the approach to signals that can give drivers sufficient warning of the route set in order to be able to stop before entering it. We also looked at early indication of a route set by means of splitting distance signals that allow drivers to control their speed accordingly, and main aspect approach release from red, again slowing train down so that drivers don't enter diverging routes too fast, but only authorised to do so when they're able to see the route indication. And we also saw how MAR is used to slow trains down before entering warning routes to mitigate the risk of associated with a shorter overlap. Our approach release from red, not main aspect, is used to slow trains down before displaying a shunt aspect, authorising to enter a calling on shunt or pose route. And finally, we looked at main aspect approach release from yellow with flashing aspects that can also be used to control speed on the approach to junctions. We then moved on to look at some of the factors that constrain signal positions: the need to protect junctions and other infrastructure, need to place signals sufficiently regularly to support required capacity, the need to provide sufficient distance for coming to a standstill between a first cautionary aspect and a stop aspect, and the need for drivers to be able to see signals for a sufficiently long time to interpret their meaning. And finally, the considerations of cost, construction and maintenance. We then looked at banner repeaters that can be provided on the approach to signal to indicate where that signal is displaying a proceed aspect where visibility is in some way obstructed. Looked at 2-aspect banner repeaters that can display a black horizontal and inclined black line on a white circular background, and 3-aspect banner repeaters which introduce the black inclined line on a green circular background. We saw how split banner repeaters may be provided with a separate indication for each route. And finally, we looked at AWS, the automatic warning system, on the approach to signals and advanced warning indicators of speed restrictions, the indications it's presented into the driver's cab if the signal is displaying a proceed aspect, and if it's displaying a restrict aspect. And finally, we looked at the train protection and warning system, TPDOS, which is provided at some signals and speed restrictions to supplement AWS, and consisting of a train stop sensor, TSS, and one or more overspeed sensors, OSS.